Hello, and welcome to the GridGain University Microlearning Unit, Getting Started with Apache Ignite Compute Grid. Over the next few minutes, you'll learn about the Compute Grid in Apache Ignite and how you can use it to solve computational problems using distributed computation. You will see how to submit individual tasks for execution and ways to implement the MapReduce pattern with distributed data and colocation. Apache Ignite Compute Grid allows distributed computing, which means combining the resources of multiple computers to solve a problem faster and more scalable than a single computer could. Benefits of solving problems with distributed computing include flexible horizontal scalability and better performance. Adding more compute nodes to the cluster typically gets faster results, which are also more resilient to hardware failure. Apache Ignite's Compute Grid distributes computational workload by sending tasks to cluster nodes where they are executed. The Compute Grid splits up large jobs, distributes tasks across nodes, and utilizes the available grid CPU computation power to execute parallel tasks concurrently. It's also load balanced and fault tolerant. Ignite gives you flexibility on how you can submit tasks to nodes. For example, you can submit tasks for execution on a single node or a subset of cluster nodes. Apache Ignite includes a number of different ways to distribute workload. We're going to focus on 3 simple APIs that allow you to execute tasks or units of work across multiple nodes in your cluster. For more sophisticated use cases, Ignite implements the MapReduce computational pattern via the compute task interface. Check out the documentation for more details about that. Recall that a closure is an anonymous function that captures all the values it needs from the scope we defined it in, so that it can be passed around as an argument and evaluated somewhere else. You can define code to run in a compute task by implementing the Ignite closure interface. To execute an Ignite closure, use the apply or call method of the compute interface. The methods accept a task and an input parameter for the task. The parameter is passed to the given Ignite closure at execution time. Ignite Runnable is an extension of Java Lang Runnable that can be used to implement calculations that do not have input parameters and return no result. To execute a runnable task, use the run method of the compute interface. The task is sent to one of the nodes associated with the compute instance. Ignite Callable is an extension of Java Util Concurrent Callable that returns a specific value. To execute a callable task, use the call method of the compute interface. Just like Runnable, the task is also sent to one of the nodes associated with the compute instance. Apache Ignite also supports the broadcast method. By default, broadcast executes a task on all nodes, but it can also execute tasks on a subset of nodes, using a cluster group object to define that subset. Since you don't always want to wait for a task to be completed, tasks can also be run asynchronously. In fact, all methods described in the previous section have asynchronous counterparts. The asynchronous methods return an Ignite future, which can be used to check on the status or wait for the result of the operation. You can set a timeout for task execution. If the task does not finish within the given time frame, it will be stopped, and all jobs produced by this task will be canceled. To execute a task with a timeout, use the withTimeout method of the compute interface. Ignite also supports reducers. An Ignite reducer collects multiple values and reduces them into one. Reducers are useful in computations with the results from multiple tasks which need to be reduced into a single result. To execute an Ignite reducer, we use the following methods of the compute interface: apply and call. Apache Ignite provides predefined reducers like int_sum reducer, string concat reducer, and even a convenience class, the always true reducer. You can implement the Ignite reducer interface to create a custom reducer. Colocated computation is where a compute task you want to perform on specific data is sent to the nodes where that data is already located, and so only the results of the computations are sent back. This approach minimizes data transfer between nodes and can significantly reduce the task execution time. The compute interface provides the affinity call and affinity run methods that collocate a task with data either by key or by partition. The affinity call and affinity run methods guarantee that the data for a given key or partition will be present on the target node for the duration of the task. To send a computational task to the node pointed by a given key, use the following methods with the key argument. And to send a computational task to the node where the partition with a given ID is located, use the following methods with the partition ID argument. To find out more about collocation and affinity, see the microlearning units, collocation and affinity, and distributed data on the GridGain University platform. Peer class loading. With peer class loading enabled, a job can be defined in a class on one node, and Ignite will automatically deploy and run that class on any other node where it is needed. In summary, distributed computing is an excellent way of making use of multiple resources in a scalable and cost-effective way. With colocation, network latency can be vastly reduced, enabling better performance. The Apache Ignite Compute Grid is a rich interface for distributed computing, and there are a few topics we haven't touched on, although this microlearning unit is a good start. You can read more about the topic in our documentation. Happy computing!